everyone, my name is Minisethi. I hope you all are staying healthy. Today we are going to talk about Gauss Markov Theorem. First of all, we must know what is OLS. OLS represent ordinary least square. We have already discussed about this equation in simple linear regression model. Y represent independent variable, X represent dependent variable, E represent error term, alpha and beta are our parameters. OLS is a method to find optimum value of parameter alpha and beta. OLS is a method to find optimum value of parameters alpha and beta. According to Gauss Markov Theorem, estimator of OLS are best linear unbiased estimators, or you can say that blue. B represent best, L represent linear, U represent unbiased, E represent efficient estimator or simple estimator. One by one we discuss about each term. First of all, we are going to talk about unbiased estimator. Biasness is opposite of unbiasedness. Biasness is opposite of unbiasedness. Biasness simply represents some errors are involved. If zero errors, that means no biasness. If no biasness, it will be called unbiasedness. So we can say that biased estimator means difference between expected value and actual population value. Suppose expected value is 10,000 but actual population value is 9,850. This difference showing some errors are involved, that's why it will be called biased estimator. So biased estimator are difference between expected value and true value of parameter. This shows expected value, this shows true value, and difference between these true values showing estimators are biased. But if expected value is equal to true value, that means no errors are involved. If zero errors, it will be called unbiased estimator. So this will be called unbiased estimator because here expected value is equal to true value of a population. Unbiased property closely related with the sample size. If you increase sample size, then biased estimator decrease and your estimator will become more accurate and reflect the true value of population. For example, you judge overall personality of individual only on the basis of celebrities' personality, then obviously your decision involves biasness. But if you collect data from different states, cities, culture, then observe personality of individual, then obviously your decision will be called unbiased because now you have increased your sample size. So we can say that biasness closely related to sample size. If you increase sample size, then biasness will reduce and your estimator will become more accurate and reflect the true value of population. According to Gauss Markov Theorem, OLS estimator are unbiased under some assumption, not always. Now we are going to talk about best estimator. And estimator is considered to be best when it has the smallest variance among all other unbiased estimators. Estimator considered to be best when it has smallest variance among all other unbiased estimators. For example, you have two unbiased estimator, one with the smaller variance is considered best because it will give estimators which are closer to true value. We have two variants, beta 1 and beta 2. Variance in beta 1 is less as compared to beta 2. That's why beta 1 is considered best estimator because an estimator is considered best when it has smallest variance among all other unbiased estimators. Best estimator, or you can say that minimum variance property, both are same. Because best estimator means minimum, or you can say that smallest variance. Minimum variance property is only desirable when it combined with unbiased property. Minimum variance property is only desirable when it combined with unbiased property. That means an estimator should consist of both minimum variance property as well as unbiased property. For example, if estimator has a low variance but highly biased, it is not considered useful. Similar, unbiased estimator with high variance can be problematical. So we can say the estimator should consist both properties, unbiasedness and small variance. Estimator which is unbiased as well as it has minimum variance is called minimum variance unbiased estimator. Now we are going to talk about efficient estimator. Your estimator will be called efficient if it has both properties, unbiasedness and minimum variance property. Your estimator will be called efficient if it has both properties, unbiasedness and minimum variance property. That means efficient estimator not only provide accurate estimator which is obviously unbiasedness, but also provide minimum variance property. And your estimator will be efficient when you use sample mean to estimate population mean. Sample mean is unbiased because you are using all available data, and sample mean cluster around population mean, so there is less chance of variance. Now we are going to talk about linearity of estimator. Our estimator will be called linear if it shows a linear combination of sample observation. Our estimator will be called linear if it shows a linear combination of sample observation. Linear combination means it shows a straight line relation in graph, not like a curve. The straight line shows a linear relationship between dependent and independent variable. And the power of variable will always equal to 1, not like a square or a cube. In case of linear properties, we mainly focus on behavior of dependent variable in relation to other independent variable. Here y is dependent variable, so we mainly focus on behavior of y in relation to other independent variable. In case of linear relationship, dependent variable will proportionally change with respect to change in independent variable. For example, if independent variable will double, then dependent variable will also roughly double. It will be called linear relationship. So this is all about today's videos. I think you got it, and thank you so much for watching this video. Bye, take care.